If we plug in negative infinity, we have 1 plus e to the negative infinity, and e to the negative infinity is 0. So this is 1 raised to, and then e to the negative infinity, so e to the positive infinity, which is infinity. And this is an indeterminate form. It is an exponential indeterminate form, and so for those we introduce a natural log. So we let y equal the function that we have, 1 plus e to the x raised to the e to the negative x, and then we take the natural log of both sides. And of course the reason we do that is that it allows us to pull the power, e to the negative x, out in front. And when we do that, as x goes to negative infinity, this becomes infinity times 0. And we'll always do that when we have an exponential indeterminate form. Well, so we're going to be taking the limit here of both sides. Now, because this right side is the form of 0 times infinity, we know that we're going to take one of those factors and drop it down into the denominator. And so instead of times e to the negative x, we're just going to write this as over e to the x. And now this is of the form 0 over 0. And so we can apply L'Hopital's rule. Well, so we take our derivative of the numerator. The derivative of natural log of something is 1 over that thing. And then times the derivative of the inside, which is simply e to the x. And then the derivative of the e to the x down there is e to the x. And so those cancel each other out. And now as x goes to negative infinity, we have 1 over 1 plus e to the negative infinity. And e to the negative infinity is 0. And so we end up with just 1 over 1 plus 0, which is 1. And now we're taking the natural log of the limit of the natural log of y. And so because the natural log is a continuous function, we can bring the limit inside. So this is the natural log of the limit as x approaches negative infinity of y. And that's equal to 1. And so now we can take e raised to both sides, and we are left with the limit as x approaches negative infinity of y, which is that function that we started with, 1 plus e to the x to the e to the negative x, is equal to e to the 1, or simply